Hello, my name is Chimbly, and in today's video I'm going to be showing you some Cheerio mathematics. Specifically, I'll be showing you the best statistical analysis to perform on a box of Honey Nut Cheerios. Quick disclaimer, don't use any other kind of Cheerio here because it's really going to skew the results. Before we begin, I suggest getting out your calculator and then some paper and a pen to be doing these calculations alongside me. If you haven't taken a statistics class before, don't worry, these calculations will appear on the side. You're also going to need some counting bowls, and I would suggest getting some desired milk to enjoy the Cheerios after. And for this, you'll not be needing the can opener, so don't worry about that if you don't have one handy. Another quick note before we begin, there are different sizes of Honey Nut Cheerios. I would definitely suggest using just the regular. It's going to be the most reliable. However, these calculations should work on large and family size boxes of Cheerios as well. I would suggest having 3 bowls. You have Group A, Group B, and Group C. Now we're going to begin by pouring a bowl of oats into Group A, and I would suggest opening up your bag all the way so that you have a lot of room to work with. That looks like a pretty good bowl of oats right there, and we're going to do the same thing for Group B and C. Now, if you have any leftover Cheerios, like I do right now, let's just roll them up and tuck it to the side. We'll get back to these in a little bit. Now you're going to remove 10 Cheerios from Group A, 10 from B, and 10 from C. Now remove the 10 Cheerios from each group. What we're doing here is adjusting for manufacturing error. Next, you're going to flatten each bowl of Cheerios to the best of your ability and choose the one that seems the biggest. Now to me it looks like Group A is just barely the biggest, so I'm going to bring that forward and count all of the Cheerios in Group A. Do the same for the remaining 2 groups to get your total number of Cheerios in each group. Once you've done that, take your excess Cheerios that we put aside a little bit ago and pour them out. Now count the number of excess Cheerios. If you did not have any Cheerios, this number will be 0. Put the excess Cheerios back in the bag and subtract 1/3 from each of the total numbers in Group A, B, and C. What we're left with is 3 sample groups that have been adjusted for manufacturing error and for Cheerio remainder. We're going to perform some calculations on Group A, Group B, and Group C. So Group A is the first of 3 of these adjusted sample bowls that we're going to analyze, and we're looking to determine the average quality of each bowl, ABC, to know if overall this was a good box of Cheerios or not. So we'll begin by understanding the standard distribution of Cheerios, and all this information can be found in the General Mills Cheerio Quality Assessment Report. This here is the general standard distribution curve, and as a reminder from your statistics class or whatever, 68% of the observations will fall within 1 standard deviation of the mean value. So in Cheerio terms, we have the snappiest, most evenly glazed, and most flavorful individual oat circles, which are essentially observations on the far right here, with the most repulsive oat circles on the far left here. Now these are going to be the best of the best over here, the most delicious oats, the ones that really keep you up at night. And our analysis will focus on the first 2 positive standard deviations because this range is considered the good oat range. So first we have to calculate the oat standard deviation, and this is the formula. So essentially we're taking the excess oat count that we already found and subtracting the adjusted bowl number, and then we're going to multiply that by itself and then put it all over the adjusted bowl number again. We're going to take the square root of this and multiply it by the oat constant of 2.9. Now this is the natural oat constant. We'll get to the factory oat constant in a little bit. Doing the calculation gives us an oat standard deviation of 30 for bowl A. So let's compare these results to factory results. Now it's stated in the Cheerio report I mentioned a bit ago that Honey Nut Cheerios have the average bowl size of 160 and the average standard deviation of 26. And this is a reminder that there's a factory oat constant of 2.1. This is not the nature oat constant when a bowl is outside of the factory. This is due to some really high-level mathematics that for the purpose of this video we don't have to get into. Here's the formula for the factory bowl of oats. And here it is filled in, and take note that there's no oat remainder like there is in a natural test like the one that we're doing now, because this is a controlled factory environment. So let's compare the oat distributions that we just calculated. And in doing so, we see that in Group A, in the good oat range, which is 2 standard deviations, there's a total of 60 oats.
Whereas in the factory group and the 2 standard deviations, there's only 52 good oats. So this is a difference of 8 oats, and this is essentially a spoonful of oats, and it doesn't sound like much, but for just one bowl, that's a really big difference. So now let's calculate our groups B and C, and remember that the factory oat standard deviation we just calculated is going to stay the same. So in group B, or bowl B, whichever you want to call it, we again have that same excess oat count of 46. Now we're going to subtract the new adjusted bowl number of 150. We're going to multiply that by itself, put it over that adjusted bowl number of 150. We're going to take the square root of that and multiply our answer by the oat constant, the natural oat constant of 2.9. This gives us an answer of 25, but remember that the good oat range is 2 standard deviations, so we're going to multiply 25 by 2 for a total of 50 oats in the good oat range in that bowl. And when we subtract this by the good oat range for the factory bowl, we actually get -2, meaning that bowl B has 2 less good oats in that good oat range than your average factory bowl. This is a little bit disappointing, but it's nothing to be unexpected. If you're doing 3 bowls, at least one of them is probably going to be a little bit under that factory standard. So moving on to bowl C, we're going to do the same calculations we did for bowl B. I would suggest pausing the video here if you want to do them yourself. Okay, so we see that there's an oat difference of 4. Now, this means that there's 4 better oats in bowl C than the factory standard. That's great, not quite as much as A, much better than B, and so I'm happy with bowl C as well. Overall, our samples were really good. I'm pretty happy. Only one of them was below the standard, and it was only below by 2, so really can't complain. This means that this was a pretty darn good box of oats. Overall, the oat quality was very nice. There are a lot more oat statistics we could be doing right now. However, I think I'm going to stop it here because this is just the introduction video and I don't want to overflood you with too much information. So on that note, my name is Chimbly. Thank you so much for watching, and I hope you learned some oat mathematics, specifically some Honey Nut Cheerio statistics. Have a good one.